Welcome to a lesson on finding the equation for a line using the information in a graph or a table. The equation of a line, one form is slope y-intercept form or slope-intercept form, y equals mx plus b. So the process of finding the equation is to find m and to find b. Now b is the y-intercept. Now, just a reminder about slope. A positive slope means the line is rising to the right in a graph, and negative slope, the line is falling to the right in the graph. To find the slope from a graph, we can use the fact that slope is rise over run, and that's a very convenient way to think of it when you're looking at a graph. From a table of values or points, delta y over delta x, which is y2, minus y1, that's delta y, over delta x, which is x2 minus x1, is very useful. So we will tend to use delta y over delta x in tables. First, we'll start with graphs. So here's the first graph. And the question asks us to find the y-intercept and the slope, and then to write the equation. So I'll go through them in detail, starting with this first one. The y-intercept happens where the line crosses the y-axis. This is the x-axis. This is the y-axis, right? So where does it cross the y-axis? Well, right here, I'll color it in blue. And the y-intercept is 1, so b is 1. Now, if we get the slope, we want the rise over the run. So what we do to find that in a graph is to draw a triangle. Oh, I'll draw a triangle. No, that isn't what I meant. Okay, you have to draw a triangle, and the line is one side of the triangle. So in theory, you could draw a very small triangle like this. And you want one side to be vertical and one side to be horizontal, rise being vertical and horizontal being the run. But that's not really that convenient. You want to draw a triangle that allows you to figure out the rise and run easily. If I drew a triangle here, and don't copy this just yet, the rise is going up a total of 1, and the run is a half. Now that's okay, but it's not convenient. We have to do the ratio and figure out the number, and we have fractions. It would be fine, it would work, but it's not convenient. What would be more convenient is to do something where we count in whole units. It doesn't have to be, but it's more convenient. So for example, this triangle has a rise of 2 and a run of 1. So that would be 2 over 1, or simply 2. That's not the only one that's convenient. I'll draw a second triangle. You don't have to copy this one, but just pay attention to it. I could draw a really large triangle. Okay, notice the line is one side, the hypotenuse if you like. The rise is vertical, so how many units up did we go? Went from -1 to 3. That's a rise of 4, right? And a run, we went over how many? 1, 2. The run is 2. So the slope would be rise over run, 4 over 2. Well, what does 4 over 2 reduce to? It reduces to 2. In fact, you can use any triangle at all, as long as the line is one side and you have a vertical rise and a horizontal run. The only thing is you want to make it easier to count out. Okay, so I'm going to erase that extra one because it's really just 2 over 1 is the simplest thing. Okay, and then the last step, and sometimes people forget to do this step because they've done all the work before that, is I would always write down y equals mx plus b, and then replace m with the value of m you found, so that's 2, so 2x, plus b, so plus 1. And there's the equation for the line for that graph. Okay, is it rising to the right? Is it going up twice as quickly as it's going across a slope of 2? Yes. Is the y-intercept 1? Okay, so that's the first example. Next example, pause the video, look for the y-intercept, and see if you can find a convenient place to draw your right triangle. If you do, find the rise and the run. Okay, now hopefully you've done that, and now you're looking at this to correct your work. The y-intercept is right here, so that is at positive 2. I'm looking at this. It's a very steep, negatively sloping line because it's going down to the right. I like this spot right here, so that's the triangle I've chosen to draw. Again, you can draw other ones, but this one avoids any fractions or partial units for the rise or the run. So the rise, and it's going down to the right, so the rise is -3, and the run is equal to 1. So the slope, which is rise over run, is -3 over 1, which is -3. Okay, so it crosses the y-axis at 2, goes down 3 and over 1. Slope, y equals mx plus b. So y is equal to, m is -3, so -3x, plus b, so plus 2. And there's the equation for the line of this graph. Okay, pause the video, try the next one. Okay, this is -2 where it's crossing, so the y-intercept is -2. Looking for a nice triangle to draw right here. And it's going up to the right, so the rise is positive 2, and the run is 3. Oh, it's not going to reduce, but that's okay. Fractions are fine. It makes it really clear that it's up 2 and right 3. Okay, so y equals mx plus b. So y is equal to 2/3 times x plus -2, or just -2. There's the equation for this line. Next example. This is more of an application question. It doesn't really tell us what it's about. I think it's probably a value of a car. I'm imagining over time. Okay, so value versus time. There we go. Notice that the value of the car drops. Question whether this is realistic or not. Who knows? Maybe it's something else. I don't know. But the y-intercept here is what? Okay, so let's look at the scale. It's the vertical scale. Notice we have 0 here. So this is the intercept right here, right? So let's see, 12, 13, 14, 15, 15,000. Okay, 15,000. And I need to do a slope. And again, I want something convenient. And I'm not liking my options that much. Oh, wait a second. I'm looking for places. Oh, it's actually not so bad. It's just not crossing major grid lines, but smaller grid lines, it's crossing quite frequently. I could do the whole thing, but this is 7, that's 7.5 years. Maybe I'll do here. That's 7 years exactly. So let's just see. So I'm going to draw a triangle, and it is appropriate, unless it's the textbook, to draw on your graphs, okay? When you're doing analysis of graphs, you draw on the graphs. It's actually acceptable, unless it's the textbook or a friend's work, I guess. So the value, the rise, is going down $14,000. And the run is 7 years. So remember, slope is rise over run. It's going down $14,000 in 7 years. So it's negative $2,000 in 1 year. Okay, notice I even put units on it because this has units. Now the equation, no, this was dollars, of course. The equation then would be value, and we can use X, but let's do value is 15,000 minus 2,000 times time. Now we normally put it in other order, but that order I had there sort of makes sense given the context I've applied to this example. Okay, there we go in descending order. Oh, copier. Value of oh, it does say copier. I'm just blind. Copier. Value of a copier over time. Okay, so value is equal to, I'm just going to rewrite the equation. and V is 8,000. So when will that be? Now, there are two ways to do that. We could do it off the graph, but I'm going to show the equation, then I'll go to the graph. So 8,000 okay, so I plug in the value into the equation. I subtract 15,000 from both sides of the equation, leaving negative 7,000 on the left side and negative 2,000 t on the right side, because those cancel out. Now I'm going to divide both sides by negative 2,000, and I get 3.5 for t. It will be worth $8,000 after 3.5 years. That's an expensive copier. Holy cow. Okay, let's go back to the graph for just a second. Let's look at this from the, let's verify this using the graph. So here's 8,000. So the way you would verify this in the graph and show your work if you're asked to, and we weren't here, so you wouldn't have to do this. The expectation here is to use the equation, but then to verify it. Come down here, you come all the way down to right here. This is in the middle of 2, so this is 3, and this is 3.5. Yeah, so that works. Of course, the graph would have been much quicker, but the whole point here is to learn to use the equation. Okay, so pause the video, think about this, go through the example, make sure you understand it before you move on. Now we're getting the equation from a table. This is a really weird looking table. In the middle is the t-chart that we've been doing when we do table of values to graph. There's the t-chart, emphasize the t. That's what we've had before. But instead of us making the table is given to us and we're asked for the equation. We've been doing the reverse. We were given the equation, we made the table. And the version of the slope we want to do is delta y over delta x. And notice we have columns delta y and delta x over the table. So I'll start with delta y. And I often put a little arrow mark here like that. And what we're going to do is 19 minus 24. And that's negative 5. And the idea here is that as you go down the table, what's the y value changing by? Well, the y value is going down by 5. So the delta, as you go down the table, is negative 5. And the table is always set up that the x values get larger as you go down the table. It's the equivalent of moving to the right on a graph. Now we're going to do the same sort of thing for the delta x. So it's negative 1 minus negative 2. You have to really be careful of those signs. The double negatives there mess people up. And you can see that the x values are going up by 1. I mean, that's what we're doing. If you want to do the manual calculation, you can see how I did it. But that's the idea. X's are increasing by 1. The y's are decreasing by 5. So it's negative 5 over 1, which is just negative 5. So there's the slope. The y-intercept happens when x is equal to 0. So let me write that down. Y-intercepts on a graph, of course, it's where it crosses the y-axis. Y-intercepts happen when x is equal to 0. And that's right here. So what's the y-intercept? 14. So now all that's left is writing the equation. We start with y equals mx plus b. We know what m is. It's negative 5x, and b is 14. Here's the first one. Give the next one a shot, then roll the video. What is the delta y? Well, y is going up by 5, going up by 5, going up by 5, going up by 5, all the way along. The x values are going up by 3, going up by 3, going up by 3, going up by 3. So it's delta y over delta x. So it's 5 over 3, and that doesn't reduce, and that's fine. When does the y-intercept happen? The y-intercept happens when x is equal to 0 which is right there. So the y-intercept is 4. If you haven't yet, pause the video and write your equation. When you're writing the equation of a line, always start with y equals mx plus b. Write that down. I do that. It's a good habit. Okay, it keeps me from making as many silly mistakes. M is 5/3, and the y-intercept is 4, so plus 4. Okay, that's it for that part. So on to the next page of the note. We have one more of these, so pause the video and give it a go, and then start it up and see if you can match. Okay, x is going up by 2. So delta x is 2. Y is going up by 1. So slope is delta y over delta x. So it's going over 1 over 2. And, x is 0 when? I'm trying to get the y-intercept. Well, it would be here in the table, so I'm just going to sort of add it in. It's right in the middle. So what's in the middle of -1 and 1? Well, 0. Good. So what's in the middle of 2.5 and 3.5? Well, it's 3.0, so just 3. Y equals mx plus b. Y is equal to 1/2 x plus 3. The table shows the amount of money Thomas earns from driving truck every day. Okay, so he's paid by the kilometer, it looks like. He earns $50 if he doesn't drive any distance. If he drives 200 kilometers, he earns $100 and 400, 150. So the distances are going up by 200 kilometers, 200 kilometers. And the earnings are going up by $50. Identify the initial value. Oh, I did the table. It didn't ask me to do that yet, but here we go. Identify the initial value. That means the same thing as the intercept. It's when the kilometers are 0 or x is 0, so that's right here. So it's $50. It's his base pay, even if he doesn't end up driving, I guess. Rate of change or slope. Rate of change is another way of saying slope. So delta y over delta x from the table. It's $50 and 200 kilometers. And what this amounts to, if you reduce it, is a quarter. But because it's money, I'm going to do 25 cents a kilometer. That's a driving pay, I guess. I wouldn't pay for a truck, running a truck these days. So his pay is $50 plus 0.25 times the distance he drove. You could use other variables, his pay. You could use E for earnings, I guess. What is Thomas's pay if he drove 672 kilometers? So D is equal to 672 kilometers. His pay will be $50 plus 0.25 times 672, which is $50 plus 168, 218. So I should use words, right? Because it's a word problem. He earns $218. How many kilometers did Thomas drive if he was paid $230? Well, that's going to be a little bit more than the last part there. Let's see how much more. So his pay is 230. We plug that into the equation. So 230 is equal to 50 plus 0.25D. Subtract 50 from both sides. 180 is equal to 0.25D. How is the 0.25 attached to the D? By multiplying. So we divide by 0.25, and we get 720 is equal to the distance. So Thomas drove, to earn his $230, Thomas drove 720 kilometers. That's a lot of driving. He must be working on the highway to do that much in a day. And I think that's it for the examples for this lesson.